Introducing Grade 11 Chemistry, SCH3U. Students in Grade 11 Chemistry, SCH3U, will engage in a comprehensive study of chemical properties and chemical bonds, deepening their understanding of the atomic structure, bonding forces, and interactions that underlie chemical substances and compounds. The course will focus on chemical reactions and the quantitative relationships within these reactions, allowing students to analyze the stoichiometry, energy changes, and reaction mechanisms that govern chemical transformations, and develop skills in balancing equations and interpreting reaction kinetics. Through investigations into solutions and solubility, students will explore the behavior of substances in aqueous environments, understand factors influencing solubility, and study the principles of solution chemistry, colligative properties, and acid-base equilibria. The study of atmospheric chemistry and the behavior of gases will provide students with insights into the composition of Earth's atmosphere, the role of pollutants, greenhouse gases, and ozone depletion, and how chemical principles influence the dynamics and quality of our environment. Students will further enhance their analytical skills by investigating qualitative and quantitative properties of matter, engaging in experiments, data analysis, and problem-solving activities to deepen their understanding of chemical principles and their practical applications. The course will involve exploring the impact of common chemical reactions on society and the environment, addressing topics such as pollution, waste management, industrial processes, and sustainable chemistry practices, and encouraging students to consider the ethical and environmental implications of chemical activities. Aligned with the Ontario curriculum for grades 11 and 12, Science, 2008, revised, the course is designed to offer university credit, emphasizing the development of critical thinking, problem-solving, and laboratory skills necessary for higher education and professional careers in science and technology. With a prerequisite of SNC2D, Science, Grade 10, Academic, the Grade 11 Chemistry course provides students with a solid foundation in chemical concepts, laboratory techniques, and scientific inquiry, preparing them for advanced studies in chemistry, biochemistry, environmental science, and related fields at the post-secondary level. This course is comprised of 5 units and a final assessment as follows. Unit 1. Matter, Chemical Trends, and Chemical Bonding. 19 hours. Students will develop a comprehensive understanding of elemental structures, allowing them to predict the physical and chemical properties of elements, compounds, and mixtures, and to recognize patterns and trends in the behavior of elements within the periodic table. The unit will emphasize the investigation of the physical and chemical properties of compounds, providing students with insights into how molecular structures, bonding forces, and intermolecular interactions influence the behavior and reactivity of substances in chemical reactions. Students will delve into the different types of chemical bonds, such as ionic, covalent, and metallic bonds, understanding the principles of bond formation, stability, polarity, and how these bonds contribute to the structure and properties of various compounds. The curriculum will focus on the prudent use and application of chemicals, raising awareness about the importance of minimizing risks to human health and the environment through responsible chemical handling, storage, disposal, and adherence to safety protocols. The unit will explore the ethical considerations and environmental impacts associated with chemical use, guiding students to make informed decisions about the safe and sustainable application of chemicals in various settings, including laboratories, industries, and everyday life. By examining the responsible and appropriate application of chemicals, students will learn about practices that protect human well-being, prevent accidents and chemical hazards, and promote environmental sustainability by minimizing pollution, waste, and the negative effects of chemical exposure. Through hands-on experiments, case studies, and discussions, students will develop critical thinking skills to assess chemical risks, evaluate safety measures, and propose solutions to ensure the responsible and ethical use of chemicals in diverse contexts, contributing to a culture of safety and sustainability in chemical practices. Unit 2. Chemical Reactions, 19 hours. Students will actively engage in hands-on exploration to showcase their understanding of the predictable nature of chemical reactions, conducting experiments to observe, analyze, and predict the outcomes of various types of chemical reactions. Through practical laboratory investigations, students will explore different categories of chemical reactions, such as synthesis, decomposition, single replacement, double replacement, and combustion reactions, identifying key characteristics and reaction patterns to deepen their knowledge. The curriculum will guide students in critically assessing the significant implications of chemical reactions, prompting them to consider the impact of these reactions on society and the environment, including their role in industrial processes, energy production, waste management, and pollution control. The unit will provide real-world applications of chemical reactions, illustrating how these reactions influence daily life, technological advancements, and environmental sustainability, and helping students recognize the practical relevance of chemical principles in addressing global challenges. By adopting an integrated approach that combines theoretical understanding with practical applications, students will develop a holistic perspective on chemical reactions, appreciating not only the scientific principles involved but also the broader societal, economic, and environmental implications of these reactions. Students will explore how chemical reactions are fundamental to various industries, technologies, and natural processes, from pharmaceutical manufacturing and materials synthesis to environmental remediation and climate change mitigation, emphasizing the role of chemistry in addressing contemporary issues. Through critical analysis and reflection, students will gain insights into the consequences of chemical reactions, considering their benefits and risks, ethical considerations, and potential impacts on human health, ecosystems, and global sustainability. By the conclusion of the unit, students will have a comprehensive understanding of chemical reactions, their predictability, and their broader significance, enabling them to apply their knowledge to make informed decisions, solve real-world problems, and appreciate the interconnectedness of chemistry with the world around them. Unit 3. Quantities in Chemical Reactions, 22 hours. Students will delve into the mole concept, a fundamental unit in chemistry, to understand and quantify the amounts of substances involved in chemical reactions, enabling them to describe and interpret reactions at a quantitative level. The curriculum will guide students in applying the mole concept to establish quantitative relationships in chemical reactions, allowing them to calculate reaction stoichiometry, determine reaction yields, and assess the efficiency of chemical processes through mole ratios and stoichiometric calculations. By gaining proficiency in quantitative analysis, students will develop the skills to interpret chemical equations, balance chemical reactions based on mole ratios, calculate reactant and product quantities, and predict the outcome of reactions using the principles of conservation of mass. Students will explore strategies for optimizing chemical reactions by manipulating reactant quantities, adjusting reaction conditions, and identifying limiting reagents to maximize product yields, delve into the practical aspects of reaction optimization, and assess the factors that influence reaction efficiency and yield. Through practical exercises, laboratory demonstrations, and problem-solving activities, students will apply quantitative insights to enhance the outcomes of chemical processes, developing analytical skills, critical thinking, and experimental techniques to manipulate reactions effectively. The unit aims to bridge theoretical knowledge with practical application, ensuring that students not only understand the concepts of chemical quantities but also gain hands-on experience in performing calculations, interpreting reaction data, and optimizing chemical reactions for desired results. By the end of the unit, students will have acquired a solid foundation in quantitative analysis of chemical reactions, allowing them to confidently navigate stoichiometry, reaction efficiency, and yield calculations, and develop the skills to manipulate reactions for improved outcomes in laboratory experiments and real-world applications. This comprehensive approach will equip students with the theoretical understanding and practical skills necessary to assess, optimize, and manipulate quantities in chemical reactions, fostering their ability to engage in quantitative analysis and decision-making in various chemical contexts. Unit 4. Solutions and Solubilities, 22 hours. Students will demonstrate an understanding that properties of solutions can be described and predicted both qualitatively and quantitatively, engaging with concepts such as solubility, concentration, and colligative properties to analyze the behavior of different types of solutions. The curriculum will focus on assessing the unique physical and chemical properties of water, emphasizing its importance as a universal solvent in living organisms and ecosystems, and exploring the role of water in biological processes, hydration, and transport within organisms. Students will delve into the origins of water pollution, investigating the causes, sources, and impacts of water contamination on the environment, human health, and ecosystems, and exploring the economic, social, and environmental factors that contribute to water quality degradation. Through case studies, research projects, and data analysis, students will explore a range of economic, social, and environmental issues related to drinking water, including access to clean water, water scarcity, water treatment methods, and the implications of water pollution on public health and communities. The unit embraces a multifaceted approach that integrates theoretical concepts with real-world applications, ensuring that students not only comprehend the principles of solutions and solubilities but also engage with the complexities surrounding water resources, sustainability, and environmental stewardship. By examining the crucial role of water in supporting life and ecosystems, students will gain a deeper appreciation for the interconnectedness of water resources with living organisms, biodiversity, and ecosystem dynamics, fostering an understanding of the importance of water conservation and management. Through hands-on activities, laboratory experiments, and discussions, students will develop practical skills in assessing water quality, analyzing water samples, and understanding the implications of pollutants and contaminants on the health of aquatic ecosystems and human populations. By the end of the unit, students will have acquired a comprehensive understanding of solutions, solubilities, and the importance of water in biological systems, while also gaining awareness of the multifaceted issues surrounding water pollution, sustainability, and the broader societal and environmental impacts of water resources. Unit 5. Gases and Atmospheric Chemistry, 22 hours. Students will demonstrate a comprehensive understanding of the properties of gases, including predictability and the qualitative and quantitative description of gas behavior, enabling them to analyze gas laws, gas behavior, and the factors influencing the properties of gases in various conditions. The curriculum will guide students in evaluating the cumulative impact of human activities and technology on air quality, examining the sources of air pollution, the effects of emissions on atmospheric chemistry, and the implications for public health, ecosystems, and the environment. Students will explore Canadian initiatives and policies aimed at reducing air pollution, assessing the effectiveness of strategies, regulations, and technologies implemented to mitigate air quality issues, and understanding the role of government, industry, and individuals in achieving sustainable air quality goals. The unit will extend to personal responsibility, encouraging students to explore ways in which they can contribute to reducing air pollution and minimizing their own carbon footprint, promoting awareness of sustainable practices, energy conservation, and environmentally friendly behaviors. Students will engage with real-world complexities of air quality, sustainability, and environmental stewardship, applying their knowledge of atmospheric chemistry to analyze current environmental challenges, propose solutions for reducing pollution, and advocate for sustainable practices in their communities. Through case studies, research projects, and hands-on activities, students will deepen their understanding of atmospheric chemistry, climate change, greenhouse gas emissions, and the interplay between human activities, technology, and environmental impacts, fostering critical thinking and problem-solving skills. The comprehensive approach of the unit ensures that students not only grasp the scientific principles related to gases and atmospheric chemistry but also gain practical insights into the broader implications of air quality, pollution control, and sustainability efforts, empowering them to make informed decisions and positive contributions to environmental conservation. Final exam, 3 hours. The final exam is a proctored assessment, conducted under supervised conditions to ensure academic integrity and fairness in the evaluation process. The outcome of the final exam holds significant weight, contributing to 30% of the final grade in the course, highlighting its importance in assessing students' comprehension and mastery of the course material. Students will be required to demonstrate their knowledge, understanding, and analytical skills within the allotted 3-hour time frame, answering a variety of questions that test their understanding of key concepts, theories, and practical applications covered in the course. The format of the final exam may include multiple-choice questions, short answer responses, problem-solving tasks, and essay questions, designed to assess students' critical thinking abilities, problem-solving skills, and ability to apply learned concepts in diverse scenarios. The completion of the final exam is essential for students to showcase their learning outcomes, apply their knowledge effectively, and demonstrate their readiness to progress to the next level of their academic journey or professional pursuits. By the end of the course, you will have achieved the following overall expectations. A. Scientific investigation skills and career exploration. Students will showcase proficiency in scientific investigation skills, encompassing the areas of initiating and planning experiments, conducting research, recording and analyzing data, and effectively communicating findings, fostering their ability to engage in scientific inquiry and research methodologies. Through exploring various fields of science, students will identify and describe careers that align with their areas of interest, gaining insights into potential career pathways, job roles, and opportunities within scientific disciplines, and fostering an understanding of the diverse and rewarding careers in the field of science. The course will highlight the contributions of scientists, including notable Canadian figures, to various fields of science, showcasing their discoveries, innovations, and advancements that have significantly impacted scientific knowledge, technological development, and societal progress. By examining the work of renowned scientists and their contributions, students will gain a historical and contemporary perspective on the evolution of scientific knowledge and methodologies, understanding how scientific endeavors have shaped our understanding of the natural world and influenced human progress. The exploration of career options in science will provide students with valuable insights into the diverse opportunities available in scientific fields, from research and academia to industry, healthcare, environmental conservation, and technology, empowering them to make informed decisions about their academic and career paths. By engaging in discussions, research projects, and presentations, students will develop their skills in articulating scientific concepts, synthesizing information, and communicating effectively, preparing them to disseminate their findings, share scientific knowledge, and engage with peers and professionals in scientific communities. The course will also emphasize the importance of understanding the societal impact of scientific research and the ethical considerations associated with scientific inquiry, fostering a sense of responsibility, ethical conduct, and integrity in students' scientific pursuits. Through career exploration activities, mentorship opportunities, guest speaker sessions, and hands-on projects, students will have the chance to gain practical insights into the day-to-day work of scientists, expand their knowledge of science-related careers, and develop a vision for their future academic and professional pathways in the field of science. B. Matter, chemical trends, and chemical bonding. Students will evaluate the social and environmental impact of commonly used chemical substances, analyzing their properties, effects on human health, and implications for the environment. Through this assessment, students will propose strategies and practices to mitigate the adverse impacts of chemical substances, promoting sustainability and environmental stewardship. The curriculum will guide students in investigating the physical and chemical properties of elements and compounds. By exploring these properties, students will deepen their understanding of the behavior and reactivity of substances, developing skills in analyzing, interpreting, and visually representing chemical properties through various methods such as diagrams, models, and chemical equations. Students will demonstrate a proficient grasp of periodic trends in the periodic table, understanding patterns in atomic structure, chemical reactivity, and physical properties of elements across the periodic table. This knowledge will enable students to predict element properties and trends based on their position in the periodic table. Through the study of chemical bonding, students will explore how elements combine to form compounds through various types of chemical bonds, including ionic, covalent, and metallic bonds. Students will analyze the nature of chemical bonds, bond energies, and molecular structures, gaining insights into the forces that hold atoms together in molecules and compounds. The course will emphasize the importance of understanding the structures and properties of chemical substances about their environmental and human health impacts. By connecting chemical knowledge with practical applications, students will develop a holistic understanding of the real-world implications of chemical properties and reactions. By the conclusion of the course, students will be equipped with the knowledge and skills to critically evaluate chemical substances, identify potential risks and benefits associated with their use, and propose solutions for promoting safe, sustainable, and ethical practices in chemical industries and applications. Through hands-on experiments, laboratory activities, and case studies, students will engage with real-world scenarios, applying their understanding of chemical properties, trends, and bonding to analyze chemical phenomena, troubleshoot problems, and make informed decisions that consider environmental responsibility and human well-being. The unit will foster a deeper appreciation for the intricate relationships between matter, chemical properties, and environmental impacts, empowering students to become responsible stewards of chemical resources, advocate for sustainable practices, and contribute to a safer and healthier environment for present and future generations. C. Chemical reactions. Students will analyze a variety of chemical reactions used in different applications, including industrial processes, pharmaceutical manufacturing, energy production, and environmental remediation, assessing their significance, benefits, and potential impacts on society and the environment. Through investigation, students will explore different types of chemical reactions, such as synthesis, decomposition, combustion, single displacement, double displacement, and acid-base reactions, gaining insight into the characteristics, mechanisms, and products of each reaction type. The curriculum will guide students in demonstrating a comprehensive understanding of the different types of chemical reactions, including their defining features, reactants and products, energy changes, and reaction stoichiometry, enabling them to predict and interpret reactions in various contexts. By examining the role of chemical reactions in everyday life, technological applications, and environmental processes, students will gain awareness of the societal, economic, and environmental factors influenced by chemical reactions, fostering a holistic understanding of their implications. Students will engage in hands-on activities, experiments, and case studies to apply their knowledge of chemical reactions and assess their real-world applications, considering factors such as reaction efficiency, sustainability, and the potential benefits and risks associated with chemical processes. By analyzing the impact of chemical reactions on society and the environment, students will develop critical thinking skills, problem-solving abilities, and scientific literacy, enabling them to make informed decisions, propose solutions for sustainability, and advocate for responsible chemical practices. Through the examination of chemical reactions and their applications, students will expand their understanding of the chemical world, the interconnectedness of chemical processes, and the importance of considering ethical, environmental, and safety aspects when evaluating and utilizing chemical reactions in various contexts. The course will empower students to become knowledgeable and conscientious stewards of chemical knowledge, equipping them with the skills to recognize, assess, and navigate the complexities of chemical reactions in both practical applications and environmental contexts, promoting the safe, sustainable, and responsible use of chemical processes. D. Quantities in chemical reactions. Students will analyze how chemical quantities and calculations are utilized in various settings, including homes, workplaces, and environmental sectors, examining the role of quantitative accuracy in industrial chemical processes and evaluating the importance of precise measurements in ensuring effective and efficient chemical reactions. By investigating quantitative relationships in chemical reactions, students will explore the mathematical aspects of chemistry, analyze the stoichiometry, proportions, and mole ratios involved in reactions, and solve problems related to reactant quantities, product yields, and reaction efficiencies, enhancing their problem-solving skills and understanding of reaction kinetics. The course will emphasize the significance of the mole concept in quantitative analysis of chemical reactions, guiding students to comprehend the mole as a fundamental unit in chemistry used to quantify amounts of substances, balance chemical equations, determine reactant ratios, and predict product yields, developing proficiency in stoichiometric calculations and reaction modeling. Students will engage in practical activities and problem-solving exercises to apply their knowledge of the mole concept and quantitative analysis to interpret chemical reactions, calculate reactant and product quantities, determine limiting reactants, and understand the principles of conservation of mass and stoichiometry in chemical transformations. Through hands-on experiments, simulations, and data analysis, students will explore the relationship between reactants and products in chemical reactions, applying their understanding of quantitative relationships to analyze reaction stoichiometry, determine reaction yields, and predict the outcomes of chemical processes, fostering analytical skills and critical thinking in chemistry. By the conclusion of the course, students will have acquired the skills to assess, analyze, and solve quantitative problems in chemical reactions, developing proficiency in quantitative analysis, interpreting reaction data, and applying mathematical principles to understand and manipulate chemical quantities, reactions, and processes. Solutions and solubility students will conduct a comprehensive analysis of the origins and impacts of water pollution, exploring the various sources, effects, and implications of water contaminants on environmental degradation, public health, ecosystems, and the quality of drinking water, while also examining the economic, social, and environmental challenges associated with ensuring access to safe and clean drinking water. Through investigations into the qualitative and quantitative properties of solutions, students will explore factors such as solubility, concentration, colligative properties, and chemical interactions that impact the behavior and characteristics of solutions, developing insights into solution chemistry and its applications in diverse fields. The course will equip students with the skills to investigate, analyze, and interpret the qualitative and quantitative properties of solutions, enabling them to solve problems related to solubility, concentration, dilution, osmosis, and other solution properties through calculations, data analysis, and theoretical frameworks, fostering proficiency in quantitative analysis and problem-solving in solution chemistry. By demonstrating an understanding of both qualitative and quantitative properties of solutions, students will gain practical knowledge and analytical skills to assess and predict solution behaviors, interpret data, and apply chemical principles to elucidate the physical and chemical properties of solutions, promoting hands-on experience and critical thinking in solution chemistry. Students will engage in hands-on experiments, laboratory activities, and case studies to explore the characteristics and behaviors of solutions, investigating solubility trends, solute-solvent interactions, and the factors influencing solution behavior, building a solid foundation in understanding the properties and applications of solutions in various contexts. The course will foster an appreciation for the complexity of solution chemistry, the challenges and considerations surrounding water pollution and access to clean drinking water, and the relationship between quantitative analysis and practical applications in solution properties, encouraging students to develop a nuanced understanding of the importance of water quality and the impact of solutions on society, the environment, and human health. Gases and atmospheric chemistry students will critically analyze how human activities and technological advancements impact air quality, studying the cumulative effects of emissions, pollutants, and greenhouse gases on the environment and public health. They will explore Canadian initiatives aimed at reducing air pollution and examine strategies to reduce their carbon footprint, fostering awareness of personal and collective actions that can contribute to environmental sustainability. Through an in-depth exploration of gas laws, students will investigate the principles that govern the behavior of gases, including Boyle's law, Charles's law, Avogadro's law, and the ideal gas law. By applying these gas laws, students will solve problems related to gas behavior, volume temperature-pressure relationships, and ideal gas calculations, developing proficiency in understanding and predicting gas properties and reactions. The course will focus on demonstrating students' comprehension of the laws that govern gas behavior, enabling them to analyze and interpret gas properties, predict gas volumes, pressures, and temperatures under different conditions, and apply gas laws to real-world scenarios and calculations, fostering critical thinking and problem-solving skills in gas chemistry. By exploring the relationships between human activities, technological advancements, atmospheric chemistry, and air quality, students will gain insights into environmental issues, climate change impacts, and the interplay between human actions and atmospheric changes. Students will engage with current research, case studies, and data analysis to understand the complexities of atmospheric chemistry and the role of gases in environmental science. Through practical exercises, simulations, and hands-on activities, students will investigate the behavior and properties of gases, conduct experiments, collect data, and engage in problem-solving tasks to analyze gas laws, predict gas behavior, and interpret results. By applying their knowledge of gas behavior and atmospheric chemistry, students will develop analytical thinking skills, quantitative analysis techniques, and the ability to draw connections between gas laws, environmental factors, and air quality considerations.